Right, the next type of cube that we're going to focus on is the body-centered cubic. And this is pretty much a simple cubic structure with an additional atom in the center. So let's get some practice drawing that. Let's draw our cube, and we're going to put an atom at each corner, like for a simple cube. And then we're going to put an atom right in the middle. So imagine an atom there, kind of floating right in the middle. And that's a body-centered cubic, or BCC. Now, to kind of highlight some of the properties of this, the number of atoms per cell, well, we got to have the eight uh, atoms in the corners, and there's only 1/8 of them actually inside. And then that atom that's right in the middle, that purple one there, since it's completely in the cell, we're going to add +1, and that comes out to 2. The edge length is equal to 4 times the radius over the square root of 3. You don't need to know how that gets derived, like how is that so different than the other one. It's in your textbook if you want to take a look at how it's mathematically derived, but I'm not going to require that. And it has an intermediate packing efficiency. And all that you really need to know is that it's more tightly packed than a simple cubic. So simple cubic, a lot of space. BCC, not so much space. And then the last one we look at later will be the most tightly packed one. And then the coordination number is 8. So remember that is the how many atoms one single atom is directly attached to. And I have this diagram here to kind of illustrate how this could be 8. So let's take the atom in the center here. So this is the in the center of a cube, and it's attached to all of the corners. So 1 through 8 there. And that's pretty much all the information to note about the body center cubic.